Okay, this video is going to talk about the product rule. The product rule is used to take the derivative of a product of two functions. So we know the power rule to take the derivatives of polynomial terms. We know the chain rule to take the derivative of composite functions. But now we're going to learn how to take the derivative of a function that consists of two different functions multiplied together. For instance, if we look at this first example right here, we have two functions multiplied together. We have x to the fourth times cosine of 6x. So we have this first function, and then we have this second function. The first function, x to the fourth, is a polynomial term. The second function is a composite function, the cosine of 6x. To take the derivative of this type of function, we use the product rule. All right, and we just follow this little song. You write the first function as is times the derivative of the second plus the second function as is times the derivative of the first. So 1d2 plus 2d1. So let's try it. All right, it really helps to label your functions. Our first function is x to the fourth, so when we take the derivative of the first function, that is going to be a product rule. The second function, cosine of 6x, because that's a composite function, we're going to use the chain rule when it comes time to take the derivative of the second function. So let's go. The first function as is x to the fourth. Again, it really helps to label your parts. There's the first function as is. Now it's times the derivative of the second function, so that is a chain rule. So the derivative of the outer is negative sign. The inner as is 6x, and the derivative of the inner is 6. So this whole thing right here is d2, the derivative of the second. There is always a plus sign in the middle of our product rule. Now we come back with the second function as is, the cosine of 6x. So that is the second function as is, and now we multiply it by the derivative of the first, and that is a power rule. So times 4x to the third, and that is d1. So here we have it, 1 d2 plus 2 d1. The first function as is times the derivative of the second plus the second function as is times the derivative of the first function. All right, now of course we get to simplify each term. All right, so we have this whole term and we have this whole term. So let's simplify each term. That should be y prime, excuse me, get your notation right. So the only thing we have to do is we have to put the -1 and the 6 out front. So that gives us -6 x to the fourth times the sine of 6x. You just want to clean up each term. All right? The second term, we want to get that 4 out front. Coefficients to the front of the term. So I'm going to put the x to the third with it, 4x to the third times the cosine of 6x. Okay, the next thing we can do is we can factor this whole thing. You want to think of this, you guys, as one big binomial. All right, you've got this term plus this term. All right, is there anything that we can factor out of each term? All right, well, we can factor out a common factor of 2 because we have 6 and 4. So we can put the 2 out front. And then we can factor out 3 x's because we have 4 x's here and 3 x's here. So excuse me, we can factor out x to the third. All right, and then we're going to rewrite that big binomial. Now it doesn't matter, you can factor out a -2. All right, so when you're pulling out common factors, you simply divide each term by the common factors. So if I divide the first term by my common factors, well, -6 divided by -2 will give me a 3. X to the fourth divided by x to the third will give me 1x, and then I still have this left over, the sine of 6x. Now check back. If you distribute you should get back to this term. Now to get this term here, you simply divide the second term by the common factors. So 4 divided by negative 2 is going to give us a negative 2. So that's going to be negative 2. The x to the thirds are going to cancel out, and I'm still left with the cosine of 6x. So there is my final best factored answer. Okay, number 2. Again, you have to learn to recognize, when do I start with the product rule, when do I start with the chain rule? Because we're multiplying two separate functions together, this is a product rule. This is my first function, 3x minus 8 to the 7th, and this is my second function, 4x plus 9 to the 5th. So we start out with our product rule, 1d2 plus 2d1. So the first function as is 3x minus 8 to the 7th. There is 1 as is. Now we multiply it by the derivative of the second. This is a composite function, so to take the derivative of the second function, I need a chain rule. So the derivative of the outer is 5 times something to the 4th. The inner as is 4x plus 9. And don't forget, the derivative of the inner is 4. So that whole thing is the derivative of the second, d2. Now there is always a plus sign in the middle of the product rule. Now we come back with the second function as is, right here. 4x plus 9 to the 5th. So that is our 2. Now for the derivative of this first function, that is a composite function, so that is also a chain rule. So the derivative of the outer is 7 times something to the 6th. The inner as is 3x minus 8. And don't forget, the derivative of the inner is 3. So this whole piece is the derivative of the first, d1. So there is the product rule. 1, the first function as is, d2 times the derivative of the second, plus always the second function as is times the derivative of the first. Now again, we want to think of this, you guys, as one big binomial. This term plus this term. So we have to simplify each term. So for this term right here, you want to get the numbers to the front. 5 times 4 gives me a 20 out front. All right, we still have a 3x minus 8 to the 7th right here, and we still have a 4x plus 9 to the 4th. So we just clean up each term. All right, the second term, this whole gig, you put the 7 times the 3 out front, 21. We still have a 4x plus 9 to the 5th. And we still have a 3x minus 8 to the 6th. All right, now we can factor. So, what's common to each of these terms? Is there a common factor of 20 and 21? No. But right here, 3x minus 8, there's 7 of them on this side. 3x minus 8, there's 6 of them over here. So each side has at least 6. So I can factor out 3x minus 8 to the 6th. 4x plus 9, there's 4 of them on this side. There's 5 of them over here. You pull out the smallest power that you have. So I can factor out 4x plus 9 to the 4th. Now I'm simply going to rewrite that big binomial. All right, so the first thing I'm going to do is I'm going to divide this first term by my common factors and put it right here. So the 20 is going to come down. If you look right here, these cancel out. All right, and here, if I have 3x minus 8 and I divide it by 6 3x minus 8s, I have 1 3x minus 8 left. All right, so when I divide this term by this term, I get this. Now I divide the second term by my common factors and put it here. The 21 is going to come down because there's nothing to divide that by. Now look at what cancels here. The 3x minus 8's cancel. I have 6 of them here. I have 6 of them here. They cancel. 4x plus 9, I have 5 here and 4 here, so there is 1 left. 4x plus 9. All right? Now there's the factored form. The last thing to do is simplify in here. So make sure that you bring down your common factors. Those are part of the answer till the very end. 3x minus 8, or 3x minus 8 to the 6th, 4x plus 9 to the 4th. Now I distribute. 20 times 3x gives me 60x. 20 times 8 gives me 160. Now I keep going. That plus sign comes down. And well, I have to distribute. So 21 times 4 is going to give me 84x. And then 84x there. And then this is going to give me 21 times 9, which is 189. All right, so the last thing to do right here is add like terms. Okay, so again, these common factors come down. They are part of the answer until the very end. 3x minus 8 to the 6th, 4x plus 9 to the 4th. All right, over here, we've got a 60x and an 84x. That gives us 144x's. And then if we add the other two terms that are alike, we have a negative 160 and a positive 189. That's going to give us a positive 29, yes. Okay, so there you have it. There is our final best full credit answer. Now, the majority of this work was all algebra, factoring and simplifying. The only calculus was up here in this top row, setting up the product rule. All right, so please go through this one again on your own. That is a lot of work. Number 3, we want to find d squared y dx squared. This right here, of course, is a symbol for the second derivative. All right, so in order to find the second derivative, we have to find the first derivative. All right, what rule do we start with here? Well, this is a composite function, e to the sine of x. So for the first derivative, we're going to use the chain rule. Alrighty, so the derivative of the outer is e to something. The inner as is the sine of x. And the derivative of the inner is the cosine of x. So there is my first derivative. Okay, now to take the second derivative, what rule do we start with? Well, there's two x's here, so we know it's not a composite function. We are multiplying two separate functions together. So to take the second derivative, we have to start with the product rule. This is our first function. This is our second function. So we sing our product rule song, 1d2 plus 2d1. So the first function as is e to the sine of x. So there is 1. The second, or the derivative of the second function is negative sine of x. So there is d2. All right, so the first function as is times the derivative of the second. Now we have a plus in the middle of the product rule always, and we come back with the second function as is, cosine of x. So that is the second function as is, and now we need the derivative of the first function. So that is a chain rule. All right, so the derivative of the outer is e to something. The inner as is the sine of x. And the derivative of the inner is the cosine of x. So this whole thing is d1. So that is our product rule. 1 as is times the derivative of the second plus the second function times the derivative of the first. All right, now let's simplify. Let's clean up each term. Remember, it's this term and this term. All right, so when we simplify each side, for that first term, I just want to get that negative out front. So negative sine of x, e to the sine of x. All right, and then the second term, hey, I've got a cosine and a cosine. So I have e to the sine of x, but I have cosine squared of x. All right, now, is there anything that I can factor out of each term? Remember, think of this as one big binomial. This term and this term. All right, is there anything I can factor out of each term? Well, look at this. Each side has an e to the sine of x. So I can factor out an e to the sine of x. All right, so when we do that, we just put it out front. E to the sine of x. And then we rewrite that big binomial. And we divide each term by this. So if we divide this term by this term, I'm just left with negative sine of x. And again, if I distribute, I get back to this term. To get the second term, I take the second term and I divide it by the common factor. The e's to the sine of x is going to cancel out. I'm left with the cosine squared of x. Cosine squared of x. So there you have it. There is my final best full credit answer. So again, it was a lot of algebra. There was one step here, setting up the product rule, then we just simplified, and then we factored. Calculus is all algebra. So there you have it. There's the product rule. Game on. Your turn to practice. Thanks, Calculus.